So welcome back to our series of questions we are solving for the midterm examination for Math 304. That's differential equation at the University of Liberia. So you see we have solution 2023. This is just for midterm, and then we have subsequent videos for the final exam. Question number 12 on this midterm paper says we should find the differential equation whose solution is given by y equal a cos x plus b sin x plus x cos x, where a and b are arbitrary constants. Again, we said that arbitrary constants are constants whose values can change, but then there's a difference between an arbitrary constant and a constant. Pi is a constant, but it's not an arbitrary constant. Great. So we move directly off this problem. We have y is equals to a cos x plus b sin x plus x cos x. Oh, this is actually x sin x in the question. So x sin x. This is x sin of x. Great. So to solve this problem, what we actually need to do is to differentiate that equation twice. So differentiate for the first time, and then we move on to differentiate for the second time. Why are we differentiating twice? Because we have two arbitrary constants, a and b. If we would have had only one arbitrary constant, we would have differentiated this equation only once. Or because we have two arbitrary constants, so we differentiate twice. Is that good? Great. So let's get it. If we differentiate y, we have y prime is equals to, we differentiate cos of x is negative sin of x, but then this will be negative a sin of x. If we differentiate sin of x, we have cos of x, and this will be plus b cos of x. Now, when we reach here, there is a product of two functions of x, so we have to use the product rule of differentiation, or the product rule of derivatives, that says that we should hold the first expression constant, so we hold x constant, we differentiate sin of x, that's cos of x, and then we say plus, we hold sin x constant, and then we differentiate x, that's 1. So we just rewrite the entire thing, we get y prime is equals to minus a sin x plus b cos x. This will give you x cos x, and then plus sin x. That's all we have. Now, after we differentiate for the first time, we have to differentiate for the second time, because we have two arbitrary constants, remember? So we have y prime prime, which is the derivative of y prime, is equals to, now we differentiate sin x. The derivative of sin x is cos x. So we have minus a cos x. The derivative of cos x is obviously sin x, but we have a negative, so it's negative sin x. So this is going to become minus b sin x. So like we expect you to already know the derivative of these functions. That's the reason why we're not trying to prove anything. We just tell you that the derivative is this, so that you can record that. And then to differentiate x cos x, we move on to use the product rule again. So differentiate x, that's 1. We go cos x constant plus s constant differentiate cos x. So the derivative of cos x is negative sin x. So this is going to give you minus x sin x. And then we're done with this. The derivative of this is this. And we say plus the derivative of sin x is cos x. Simple as it is. We've already completed the second derivative. Now we are seeing something here that can be added. We have cos x and cos x here, they can be added. But then we have negative a cos x minus b sin x minus x sin x, which is exactly all we had for y. But we see that all of them have negative signs. So I'm going to group all of them. So I'm going to have y prime prime is equal to minus a cos x minus b sin x. Then we have a minus x sin x plus cos x plus cos x is 2 cos x. So you see what we did? Now, we just group the next thing to do after we've done that is to obviously factor out a negative. So you asking how we got the 2 cos x, we added cos x plus cos x. That's how we got the 2 cos x. Now, if we factor out negative from these three terms, factor out negative 1, we have y prime prime is equal to minus 1, parenthesis open. This is going to become positive. A cos x is going to be positive plus b sin x is also going to be positive x sin x. Multiply negative 1 by everything here, you're going to have this plus 2 cos x. Great. Once we have that, we can recall that this entire expression in this parenthesis is y. This entire expression is y because y is a cos x plus b sin x plus x sin x. And that's the same thing here. So we have y prime prime minus is equal to, so this is minus y plus 2 cos x. And then to write the differential equation, we send this across. So we send this one across. We have y prime prime plus y equal to 2 cos x. So this is a differential equation whose solution is this. Now remember, if you solve this differential equation, you can use the method of undetermined coefficient to find the solution of this after getting the carries of this equation from y prime prime plus y equal to 0. Thank you very much for watching, and we hope you subscribe to our channel for more videos, and see you in future episodes of our classic videos.